Hi, welcome to YouWillUnderstandMath.com. Today you will understand how to prove linear limit statements using epsilon delta arguments. Before we start, have a look at this equation. It should look very familiar. It is used in order to solve quadratic equations in this form: ax squared plus bx plus c equals 0. The reason this works is because one can take this equation, complete the square, and arrive at this solution. Here's a quadratic equation in standard form where we have the x squared term, the x term, and then a constant equal to 0. On the other hand, we have the x squared term on the left side of the equation, and we have the x term and the constant on the right side. Well, you can use the quadratic formula for this equation, but you can't use it directly for this equation. You would have to first move the negative 6x term to the left side of the equation and move the constant to the left side of the equation so that you have 0 on the right side. Then you can use this formula. The same applies for epsilon delta arguments. Here's the definition of a limit. The limit of f of x, some function, as x approaches c equals L if for every epsilon greater than 0, there exists delta greater than 0, such that when the distance between x and c is between 0 and delta, the distance between f of x and L is less than epsilon. I'm going to show you how to prove linear limit statements. So our f of x will be a linear function, but the key is to acquire this, to get the distance between f of x and L less than epsilon. In the first proof, I'll show you the backwards method. And in the second proof, I'll show you the forward method. In either method, though, we'll need scratch work. In our scratch work, let's point out what c, f of x, and L are. According to our definition, c will be what x is approaching. In our case, x is approaching 4, c is 4. The function will be located here. F of x will be 2x plus 1. And L will be 9. Now, we'll begin with this statement. Remember, f of x is now 2x plus 1 minus L, in our case 9, is less than epsilon. And we're trying to find out what delta value in terms of epsilon will make this statement true. Just as in my example earlier with the quadratic formula and the quadratic equation, I had to have that equation in standard form before I could use the quadratic formula. In the same way, we need to begin with this statement, f of x minus L less than epsilon, and we need to somehow get it into the form of x minus c, in our case c is 4, is less than some value in terms of epsilon, and we'll call that value delta. That's why I have delta of epsilon. 2x plus 1 minus 9 is the same as 2x minus 8, because 1 minus 9 is negative 8, less than epsilon. Now we can factor out 2 and collect the other term. Notice this is the same as the absolute value of 2 times the absolute value of x minus 4. It will not change that at all. We almost have this form. Almost. We have the x minus 4, the absolute value of x minus 4, but we have this absolute value of 2 over here that we need to move to the other side. We can do that by dividing both sides by the absolute value of 2, but before we do that, observe that the absolute value of 2 is just 2. That would be 2 times the absolute value of x minus 4 less than epsilon. Now, let's divide both sides by 2. And we have left the absolute value of x minus 4 is less than epsilon over 2. This is what I meant by delta of epsilon. We will call this delta. Delta equals epsilon over 2. We've just found the delta that we need in order to complete our proof. Our proof absolutely has to be in this form of the definition. We will have to begin with for every epsilon greater than 0. And we have to say what our delta will be. So our proof begins like this. Given any epsilon, because it should work for any epsilon greater than 0, of course, choose delta. We know what delta is because we just did our scratch work. Delta equals epsilon over 2. We want this, but we know that our C is 4, so that for the distance between x and 4 less than delta, we're going to substitute what delta is. We have the absolute value of x minus 4 less than epsilon over 2. When I say backwards, at this point, we're about to go backwards through our scratch work. See what we have so far in our proof? We have the absolute value of x minus 4 less than epsilon over 2. We have the end of our scratch work. We need to make sure that we end up at f of x minus L less than epsilon in order to complete our proof. Here we've reversed all of the steps in our scratch work in order to obtain the absolute value of f of x minus L less than epsilon. This is what we wanted to prove. And you can finish this proof with what we wanted to prove, hence the limit of 2x plus 1 as x approaches 4 equals 9. Here's the second proof. In this proof, we'll move forward through our scratch work. We will still begin with given any epsilon greater than 0, choose delta equal epsilon over 2. And that's because we found that in our scratch work earlier. Then for the distance between x and 4 less than delta, we can rewrite our scratch work in the forward direction. We'll begin with f of x minus L, which will be 2x plus 1 minus 9. And then we'll work our way toward that being less than epsilon. Here I'm emphasizing that f of x is 2x plus 1. That's why I'm using parentheses here. And I've gotten to this point. This will be less than 2 delta because the absolute value of x minus 4 is less than delta. Now we can substitute epsilon over 2 for delta. Notice the 2's cancel out, and what I have left is epsilon. There you have it. We began with the statements from our definition, which are absolutely crucial for any proof in epsilon delta. We know that the distance between x and 4, which is less than delta, will result in f of x. Our f of x is 2x plus 1 minus L, which is 9, is ultimately less than epsilon because we started here and we got all of these equalities until we got to this point where we had a less than, which is what we need in our proof, and that is equal to epsilon. So overall, we found that the absolute value of 2x plus 1, which is our f of x, minus 9 is less than epsilon. Please like and or subscribe if you've enjoyed this video. Thanks.